All right, so I had you do the long form way on the first one, just so that you could make sure you understand how the math was being applied. So on this particular one, we are going to use the calculator, and I'm going to show you the easier way that you can actually go ahead and do this. So let's clear this out. Now, we have, in this case, for problem number 2, the question is to use your micrometer measurement on the outside diameter where the print dimension is 77 thousandths and 8/10 plus or minus half a thousand. So when we're being asked to find the mean and the median here on this, so we're going to start by entering our data. So I'm going to go 0.0774, and then we have this plus, this sigma plus. Now that is a capital sigma in the Greek alphabet, and we'll hit that. Now that's the first data set. Notice how it shows n equals 1. So let's go ahead and enter the second one, 0.0778. Again, the plus, the sigma plus here. So that's our second data set. 0.0780 sigma plus. That's the third. 0.0773 sigma plus is 4. So 0.0779 sigma plus is 5. 0.0781 sigma plus there is 6. 0.0782 sigma plus is 7. 0.0781 sigma plus is 8. 0.0784 sigma plus is 9, and 0.0782 sigma plus is 10. Now, once we've entered all of the data in our data set, we'll notice that we also have the mean symbol right here. So now that's up above the x squared button. So we need to go second, and then the mean. So there is our actual mean here of 0.07794. So we'll write that down. So make sure that you actually enter that data on your sheet. So the mean here is 0.0774. So as far as that goes, now you will need to rearrange and put in order the data set so that you can figure out the median. But one real quick thing, we're also going to put in the actual standard deviation from here. So once you get your mean with that particular set of data, notice we also have the formula right here with the lowercase sigma, x to n minus 1. So let's just go ahead and hit second and press that button. And our standard deviation is 3/10 or 3.5 tenths. So let's go ahead and write that down as well. So remember, the standard deviation symbol is the lowercase Greek letter sigma, and that's going to equal 0.00035. And again, because all of our data set was a 4-place decimals, we are going to go ahead and maintain the 5-place decimals here with the sigma. 3.5 tenths on this particular data. Again, this is kind of a fairly widespread distribution. So when our tolerance is plus or minus half a thousandths, so when we're coming up with a standard deviation of about 3/10 here, so as opposed to the 5/10 as well. So it's a pretty spread, but we're still in the safe side. We would definitely, if that were 4.5 tenths on that standard deviation, we would want to control some things better. There might be some other things that we might want to do to try to get that standard deviation a little smaller than what we're seeing. But again, use your calculator. So it does have the tools, so I don't require you to sit here and do the long form. I only wanted you to do the long form just to make sure you understood how these formulas were working and where they were coming from.